So I entered the first time, it was actually for a school project. So one of my school projects was to design an experiment of our own. And I thought that this would be an excellent opportunity for me to kind of experiment and then investigate something that I was actually passionate about.
Science Awards, the first time I just entered and I didn't really know what I was doing. But then the second time I entered was 2 years later in year 2. I had a really amazing teacher who gave us a homework assignment where we got to make a board game. And I made a game called Tree Frog Trouble, which was my first ever board game that I made. And then another teacher, who was I think my biology teacher, she came up to me and she said this would be a really good entry into the Oliphant Science Awards, and I had no idea what that was. So then I researched it a bit and decided to make my game a little bit better, and then I entered it. And I've been entering the games category and other categories ever since, up until grade 12, and now I'm 2 years into a university degree. So I entered it for quite a while.
I'm Monica Oliphant, and I'm so impressed with what they do in the Oliphant Science Award. And this year, the models and the posters, and there's some terrific things. People have done some outstanding work. It's great to see the enthusiasm from the students.
Well, I would really recommend it just because I think it's a really great way for kids who really enjoy science to sort of explore new concepts in a really fun way. Because you can sit down in class and talk about science and biology and physics and stuff like that and how it all works, or you can go out and do your own research and actually build something that represents it, and you learn a lot along the way. And then you're also showing people how it works in a really fun way, as well as learning it. And especially for people who enjoy building stuff, or I would really recommend the Models and Inventions just because I really enjoy the whole construction process and also just the research behind everything. So it's just a really fun way to learn new things alongside with school.
Adelaide welcome to the one and only exploding lady herself, Nitro Nat.
Hello everybody, have you guys had a great day? Yeah? So I'm not your typical type of scientist. I don't wear a lab coat, I don't wear crazy hair. Okay, I might have crazy hair by the end of this, but I'm a scientist. Scientists look like everyday people, which is pretty cool. Yeah! Now, today we are doing the crazy colourful chemistry show with the spirit fingers. But is there much colourfulness yet? No? Should we make some things nice and colourful? I like that, yays. Awesome. So, what I have here is I have 1, 2, 3, 4, 5 liquids. Should I drink any of these liquids? No! No! Well done. Good answer. Now, we would say sometimes that this liquid is clear. We would sometimes say that this liquid is transparent. But that is not actually the colour of the liquid. Can I get everyone please to say colourless? Colourless. So this liquid is the colour colourless. Can we all say that? Ready? 1, 2, 3. Colourless. Beautiful. Now what colour is water? Colourless. Beautiful. What colour is vinegar? It is colourless. Beautiful. We have lots of colourless liquids. And guess what? On my table, only one of them is actually water. But still, still, even though I am in a science lab condition, so I will not be drinking or eating anything on my science tables. So should I drink this colourless liquid? No! Good job, everybody. Now, I have 5 what coloured liquids? Colourless! Beautiful. And I have this really cool chemical here called universal indicator. Now, my universal indicator has 3 danger diamonds. Now, if something has a danger diamond on it, should you be touching that bottle? No. Should an adult be touching that bottle? Yeah, if they know how to use it safely. So, spectacles on, lid off, pipette out. Now this stuff is a weird greeny colour. Should I add it to our first liquid? Yeah? Alright, let's see. Put the greeny liquid in it. It's not greeny coloured. It's red. Alright. The next one should be green, right? Yeah? Yeah? Maybe? Ooh. Orange. What colour do you think will be next? Ah, it's not yellow! Gotcha! Alright, next one would be... Ooh. Bluey green, teal colour, Port Power. If you're a Port Power fan. And lucky last... Purple! Let's give these all... Oh, there's wobbly table. Lovely mix. There we go. We have a really cool rainbow. Now, do you think that these are all the same liquid? No, because I have added the same liquid to each one of these, and this liquid hasn't changed, but these have. So in front of you, we have something called a pH rainbow. This is a pH scale which tells us if something is an acid or a base. Now, hot colours, like these ones over here, are acids. And cool colours, what do you think they are? They are? Bases. Well done. Now this special one in the middle is our green, is our neutral. It's smack bang in the middle, and this is my water. The only thing that's water on here. Now if this is water, should I drink it? No. Good job. I have just added a super dangerous chemical into this, and if I were to drink this, I would need to go to the hospital. So just in case, does anyone know the number to 000? Yeah? Yeah? Alright, good. Alrighty. Now, I'm going to tell you what these lovely, mysterious liquids are. The first one we have is vinegar. And vinegar is quite a strong acid, but it's something that we can still consume, which is pretty cool. Next up, we have something special, and I will come back to this one, but tomatoes are at the same sort of pH, where it is less acidic than our vinegar. Oh, sorry, yes, less acidic, higher number, and so it sits there. What did I say our lovely green one was? It was? Water. There we go, let's put water down. Next up, we have something we use all the time, soap. Soap is a base. And also is bicarb soda. So in here I have some cool bicarb soda. And lucky last, we have a very strong base. And this is a cleaning product called sodium hydroxide, which comes off as a very strong purple, which is really pretty. Aren't they pretty? So pretty. Nah, science can be so cool. All right, up here I have another liquid. What color is this liquid? It is? Colourless. Well done. Now, if it is a cold colour, we call it a base. And if it's a hot colour, we call it an acid. And if it's green, we call it neutral. There's that word. All right, let's add our universal indicator into our measuring cylinder. Is that a little bit more? Beautiful. And let's use a trusty chopstick to give it a mix. Wee. Alright, is it an acid or a base? Base, because it is a cool colour. Cool. But do you know what else is really cool? My esky. My esky is pretty cool because it's cold. Bad dad joke. Now, the stuff inside here is actually very, very cold. Ready? There you guys are, just disappeared for a minute. Ready, magic or science? Science! Yes! No, in here I have some really cold stuff called dry ice. Have you guys ever heard of it? Yes. Yeah? And it comes in really pellets. Now, does anyone know what dry ice actually is? Yeah? Well done, it is carbon dioxide. Let's all say the magical words carbon dioxide. So let's all say carbon, carbon, and now let's all say dioxide, dioxide, and together we have carbon dioxide. Now, really cool thing, that is what we breathe out. Does anyone know what we breathe in? There's a special thing. Oxygen, can everyone say oxygen? Oxygen! Beautiful, so we breathe in oxygen and we breathe out carbon dioxide. Now this stuff is cold carbon dioxide. It is frozen carbon dioxide, a solid. So this is at a temperature of minus 99 degrees. So it's super, super duper uber cold. Now a bit of a tricky question. This might trick some of you. Why is this called dry ice? Why is it being given that name? Does anyone actually know why it's called dry ice? Yeah? It is dry, but why? Like, it's a bit of a cool, quirky thing. Yeah, over there?
Because normal ice, like water ice, if you like warm it up, it turns into water first and then into steam. But with that, it turns directly into gas carbon dioxide.
Well done, let's give this person a round of applause. So I'll say with my microphone what they said. Water ice goes from a solid to a liquid, which is why it's wet, and then into steam at 100 degrees. Now this stuff goes from a solid straight into gas, which is all around us, and isn't a liquid at all on Earth. Unless you do some really special physics to it, increase the pressure, that is the only time you can actually get carbon dioxide as a liquid. But on Earth, naturally, it goes from a solid straight into a gas, and that's why it's called dry ice. The more you know. Yeah, I'm cool in here if I keep up with the times. Yeah. Alright. We are going to add our frozen carbon dioxide to our measuring cylinder, and we are going to see a really awesome chemical reaction. Are we ready? Yeah! Are we spaghetti? Yeah! Let's do this. Ready? 3, 2, 1. Whoa! It's bubbling away. It's a bubbling and bubbling and bubbling. And what colour is it still? It's still got purple, and then we have our lovely white clouds at the top as it goes along, bubbling and bubbling away. Let's add a little bit more to it. Woo. Bless you, to the person who sneezed. There we go, it's bubbling even more. And what's happening to the colour? It's turning blue. So we've gone from purple to blue. What colour should it go to next? Green. Let's see if it will. Oh, it's got a nice green colour. And then what colour will it turn to next? We have our yellow! Yay! Our rainbow is complete. Now, really cool thing, what you can see up and around here is that the clouds are actually going down. So this means that these are cold. Which way does steam go? Up, because it is hot air, so it goes up, whereas this is cold and will go down. Now, a really cool chemical reaction happened in there where our carbon dioxide mixed around with our water and made carbonic acid. Now, have you guys ever heard of the words ocean acidification? Yeah. Some of you may have. That's where the carbon dioxide in the air is mixing around the ocean and making it slightly acidic. Now, before you guys came and sat down, I was prepping and I put a bit of dry ice into here, which is what is in this one. I put a few pellets in there and let it turn into an acid. The reason they're different colours is because there's a lot more water here, there's a lot less in here, plus I had another chemical in here for it to change colour. Just, I think it's really cool. I I think it's really, really good. All right, I have 2 liquids here, and they're not quite colourless, are they? They're a bit milky. But let's give them a shake. Ooh, it's a bluey purple. Let's see what the other one's going to do. Ready? Shake! Okay, cool. Who needs to go to the gym when you shake litre flasks? Now, have I added any chemicals to this? No, before, but when I shook them, did I add anything? No. So do you think the shaking has made the colours do some funky stuff? Yeah? In here I have some sugar, glucose, C6H12O6. Those numbers you will learn in high school and never forget them. They will forever be stuck in your noggins. And it does. It's like you learn it and it's just there. It's just there all the time. And I have some sodium hydroxide in there as well. And what is happening inside here is that there is a big tug-of-war happening. Now when I shook it, I actually got the particles to move around and they had a bit of a tug-of-war where our oxygen is winning right now. Now very, very slowly, the tug-of-war is going the other way. Now which way will it go? What colour will it turn to after this? Bluey green? It's not going to be like the pH colours. What colour was it before I shook it? It was like almost colourless. And what's happening now? They're slowly turning backwards. There is a giant tug-of-war happening inside there, and as it goes blue, our oxygen is winning, but then slowly our sugar wins and it turns back to colourless. Now my question is, which one did I shake first? Point with your fingers. Let's go. Let me do this. Point with your fingers. Which one did I shake first? This one. And then I shook this one after. But did they almost go at the same time? Did they almost turn colourless at the same time? Almost. So I shook this one later, but in a way it almost went quicker. Why do you think this one went quicker? Any ideas? Bit of a tricky one, yeah? Because it was the second one that went quicker? Quite possible. There's actually another reason. Yeah? Pardon? Oh, how much I shook? That is a really good variable. But no, the shaking, how much you shake is pretty the same, yeah? I put a different liquid in. Same liquids, yeah? There is something different about it. I put more of both of my chemicals into this one and therefore it shook a lot more faster. I'm going to shake them both at the same time. I'm going to let them go and we'll see which one turns quicker first just to prove it. Ready? 1, 2, 3. Cool. They're both going at the same time. And thinking about what we said before, this one should turn back to colourless before this one, okay? We'll let them go. We'll let them do their thing, and we're going to go destroy a gummy bear, okay? Yeah, sound good? Now, this week's Science Week theme was all about food. So, do you guys know how much sugar is in a gummy bear? A lot! So much energy in a gummy bear. So what I'm going to do is I'm going to rip apart the sugar, the glucose, the C6H12O6, see it's still in the noggin, and we are going to rip apart that sugar and show all the energy that is inside it. Now inside my test tube I have a powder called potassium chlorate, and I'm going to use my cool burner to melt it down. Ooh. And then I need your help to pick. It's all safe. I have two fire blankets, a fire extinguisher, and carbon dioxide, frozen carbon dioxide, which will help me if anything goes wrong, which it won't. Knock on wood. Or stomp on wood. Okay, so I'm melting down my potassium chlorate, so it's a liquid, and then we'll add the gummy bear to it. Now I have 3 gummy bears, and I want you guys to tell me which one I should put in. I have orange, yellow, and purple. So, who thinks we should put the orange one in? Huh? Okay, who thinks we should put the yellow one in? Ooh, okay, I'm happy with that. And hands up, we should put the purple one in. Why the purple one? They taste the best. That's why it tastes the best, so that's why we want to put it in, right? Okay, now, this is going to make some sound. It's going to go, it's not too loud. Oh, hello there. And then we are going to, sorry, I haven't put hairspray in my head today. Why aren't you doing this today? Thank you. All right. It's going to make some noise. It's going to produce some light and some smoke. Are we ready? Goodbye, purple gummy bear. 3, 2, 1. Oh. No more purple gummy bear. How cool is that? I can't get it out because I want you guys to think of a marshmallow. It will smell like burnt marshmallow because marshmallows are filled with lots of sugar. Now if we burn a marshmallow, it turns into charcoal and gets all black and yucky, and that's what's in there now. It's like burnt marshmallow. So gummy bears have so much energy stored inside them that when we release it, when we eat it, that's why we get sugar highs and we're like, whoa! And then we have our sugar crash. Alrighty. Now, what colour was that flame? Because that actually was plasma inside there. What colour was it? Purple, and then it went to white. It was like in between. It was a beautiful lilac colour. If we want to get specific, it's lilac. Cool. Let's look at some other coloured flames. Now, what I'm going to do now is I'm going to do something extremely dangerous. But everything I have done today is extremely dangerous. So do you try any of these things at home? No. Do you ask your adult at home to try this at home? No. Adults can't do this unless they are trained professional. Do you think I'm a trained professional? Nah, I'm a trained professional. I have done this for a while. You can smell the gummy bear? Yeah. Okay, what I'm going to do is I'm going to put fire on my hands. Let's go that much. All right, ready? 3, 2, 1. That's okay. Gotcha. Again? Okay. Okay, ready? Spaghetti. 3, 2, 1. Is my hand okay? Oh, thank you. Thank you. I really did my debutante, we had to do a really big circle curtsy and then go down. So hard in heels. I've learned something from that. So, is my hand okay? It is. Now, I have a very special liquid which is protecting my hands. And as the heat is burning that liquid, the liquid is turning into a gas, keeping my hand nice and safe, which is pretty cool. I can't have it for too long because then the liquid turns into a gas and all that's left is my skin. I like my skin. You're in good skin. Good job. High five. That's like a full dad joke there. Alrighty. Would you like to see it one more time? Yeah, I like this one. This time, I want you guys to concentrate on what colour the flame is. What colour is the flame? I can't do my whole arm because my arm can't hold my liquid. Ready? 3, 2, 1. Wow. What colour was our flame? Orange. Cool. Do 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 do. Da 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 da. Alrighty. Now I have a very flammable powder. So that was a very flammable gas. Now I have a very flammable powder. Alright. You know it's serious when you've got to put gloves on. Right? Alright, cool. Got those. Oh, I should have put them on before I opened my container. I goofed. Alright, cool. The flammable powder. Dun, 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 dun. 3, 2, 1. Bang! Why don't you think it is catching a light? Hands up. Why do you think my flammable, it is, trust me, it is flammable. Why it is not catching a light? Yeah. Ooh, when it's sort of like contained, the flammable risk is lower. But why? Yeah? No? Yeah? It's, because it's littler? No, the problem is that it is little. Yeah? Pardon? Well done. The oxygen can't get in between our little powder, so therefore it can't catch a light. So, I sometimes like to turn into an elephant, and I'm going to use my elephant trunk to help breathe fire. Okay? I'm going to spread apart my flammable powder, and I'm going to be a dragon. Yep. Yep. Sound cool? Yep. There we go. Now, quick question, bit of like going back to it. Did you guys realise what colour this flame was? Blue? Yeah? Cool. Alright, this time I'm going to change the colour of the flame by stopping the oxygen. I need a lighter. Does this lighter work? Yes, it does. It does a little bit. There we go. Oh, beautiful. What colour is it now? It's yellow at the top, so this is a quote-quote safety flame now. Alright, I'm going to spread apart our flammable powder, letting the oxygen get in between and also be really cool and be a dragon. Ready? 1, 2, 3. You guys felt it? How do you think I feel? I'm actually quite good. Ready? 1, 2, 3. Again? 1, 2, 3. Alright, I'll do it one more time. When I go to 3, I want you guys to roar like a dragon. Ready? 1, 2, 3. Is that cool? Yeah! Cool. What colour is my liquid? Colours! I can't do the hand signals. There we go. Colours! I'm going to add it to my lovely bowl. And I'm now going to set the flammable liquid on fire. Cool. Now, some of you may be able to see the flame in there. It's got a bit of a blue colour to it and a bit of orange. And that's the natural colours that come off it. Now, I'm going to add 3 different chemicals. This first one is called potassium chloride, very similar to the gummy bear. It's purple. So do you think it's the gummy bear or the powder that makes this purple colour? The powder, well done, the chemical. All right, next up we have some strontium chloride. Ready? Red. Cool. Lucky lost. My favourite, copper chloride. Now, people that work in pyrotechnicians, so in special effects and fireworks, they actually use these chemicals to do their jobs. Now, who here is a Harry Potter fan? Yeah, cool. I love Harry Potter. And what's the special powder they use to go to Diagon Alley? Flu powder. This is flu powder. This is something similar that they use in the movies. So we're going to go 1, 2, 3, and we're going to say Diagon Alley. Ready? 1, 2, 3. Diagon Alley. Are we there? Can I buy a wand? It's okay. No, it's my fault. I haven't connected my beaker to the flu network, so that's why it's not working. Is that a little bit more red? If I add the whole thing, only a little bit of the powder works. And I do this in a special order because now the potassium. If I mix them, the purple usually comes out, the blue comes out on top. Alright, here we go. We've got strontium and copper chloride. The copper chloride comes out on top. The potassium, the purple, won't come out at all. It's like the weakest out of them, and so that's why I do that one actually first. Now, my fire is starting to go down. Why is my fire starting to go down? Yeah? I'm not adding anything. It's used up all of its fuel source, which was the methanol, which is pretty cool. Ta-da! Cool. I think it's cool. Alright. Thank you! Shots! Alrighty. I have arrived at our last demonstration. We're at the end already! I'm so sad. Have you guys had a great day today? Yeah? Have you guys enjoyed the Oliphant Science Awards? Yeah? Alright. My lucky last thing is called Elephant's toothpaste. What colour is my liquid? Colourless. Beautiful. Now this colourless liquid is kept in a black bottle because sunlight actually makes it change. So, over a long time, this poison, hydrogen peroxide, will turn into water and oxygen. But we're going to speed it up. We're going to speed it up by using a thing called a catalyst called potassium iodide. So let's add 1. 2. We're going to go for 2.5 and hope it doesn't hit the roof. Alright, so that's going to speed up our reaction. I have detergent to get you guys to clean the dishes later on, right? No, our detergent's going to capture the oxygen that we are going to make when we break apart this. And we want some colours, don't we? Okay, I have yellow, green, blue and pink. So who wants yellow toothpaste? Oh, okay, poor yellow. Who wants green toothpaste? Okay, who wants pink toothpaste? Yeah! Okay, who wants blue toothpaste? Yeah! I think it's pink! Yeah! Yes! I'm so excited for pink because I always do blue, so it's yay, something different. Alright, cool. My name is Nitro now. I hope you guys have enjoyed the crazy colourful chemistry show. If you would like a collectible, non-collectible Nitro Nat card, come and get one off me later. And if you have any questions, I will come downstairs and have a talk to you guys. But have you guys had a great day at the Oliphant Science Open Day? Ready? Let's have a big 3, 2, 1. Ready? 3, 2, 1!
I can't wait to see everyone's project for next year. It was a really great day. Thank you.